Alright guys, so I want to talk a little bit more about residuals. The idea behind the residuals is in order to find the line of best fit is we want to find the line that ends up having the smallest residuals. And so we saw before that the way you find the residual was, so a residual was actual minus predicted. Actual minus predicted. This should look somewhat familiar. This is sort of the way we found the standard deviation, where we took the piece of data and we subtracted the mean from it. We found how far away we were from the mean, the distance from the mean. This time we're finding how far away this point is from the line. So it's similar to the standard deviation thing. Instead of finding how far the data, the point was from the mean, from the middle, now we're looking how far away is this point from this line. And so if we wanted to come up with the line of best fit, and we want to minimize all these distances, we can move this around, tweak it a little bit here, a little here, a little here, a little here, until we had the smallest distances. We'd end up with a similar problem we did with the standard deviation. If you remember with the standard deviation, we took all the distances that the points were from the mean, and we wanted to add them all up and divide and find like an average. But it didn't work because they all canceled out. If you notice, this point here had a residual that was negative. If you remember, the residual was negative 27.2. And that happened because our actual point was below the line. If the actual point was above the line, like let's say this point here is above the line, this point would have a positive residual because you would take the actual minus the predicted, and the predicted is a smaller number, so it would have a positive residual. And so if we did the same thing, kind of added up all the residuals, we would add up like a bunch of positives and a bunch of negatives, and they'd all kind of cancel out, and so it wouldn't work out so well. So something that we can do is we can take all the residuals just like before, and we can do this, and then we could square them. All right. Last time when we squared them, we got rid of that whole problem of them canceling out, and then we can add them all together. Add up the residual for each one of these. So we could say, okay, what's the residual here? What's the residual here? What's the residual here, here, and here, and here, and here, and here, and here. Notice these 2 points that we drew the line through, they have a residual of 0 because they're actually on the line. And so we can take all these residuals, find what the distances are. They can be positive, and some are positive, some are negative. We square them all, and then we can add up all those squared things. Just like with the standard deviation, we add up all those squared amounts. And what we end up with is we end up with something that says SSE, which ends up being the sum of all these squareds. All right, and so the idea is when we square all the residuals, if we add them all up, this number ought to be as small as possible. If that number is as small as possible, that means that we got this line as close to all the points as we could, because all the distances were as small as possible, right? Were the shortest distances from the point to the line. We took the residuals, squared them, add them all up. If this number, what essentially we could do is we could, draw one line, check all the residuals, find the residuals, square them, add them up, get a number. And then we could tweak the lines a little bit like that. And then find all the residuals again, and then square them and add them all up. When we do that, if we find a number that is, when we did it the first time, we got some number. If we do it again, now we get another SSE, sum of all the squares. If this one is now a larger number, we go, oh, that's no good, because now we kind of went a little further away from some of the points, so that one's no good. If we tweak the line again, a little bit, and then we get another sum of all the squares, we go, okay, well, now try it again, and now we get a number that's a little bit smaller than this one. We go, oh, this one fits a little better because it minimizes those distances from the line, so we can cross that one out, and now this one's more of a better candidate. So that's kind of a guess and check kind of way. What our calculator does is it has a bunch of formulas in it that kind of does it automatically and kind of figures it out mathematically, goes directly to the actual best line. But so that's how that works. And because we're doing these squares and stuff, that's why at the top of the page they refer to it as the least squares regression line, because that's the smallest sum of the squares. So you'll see this, the line of best fit, referred to as the least squares regression line sometimes, or just the LSR sometimes. And so that's all that means, is that we had the smallest sum of all the squared residuals. That's all that's going on there. Okay, guys. All right, so that's all I want to say about residuals for now. Now let's in this next video, let's jump into using the calculator. All right.